Now we're going to talk about sine, cosine, and tangent. And if you remember from geometry when you took it this year, they talked about the idea of SOHCAHTOA. So SOHCAH and TOA. And all that referred to is how do you calculate it? If we're talking about sine, sine is going to be the opposite over the hypotenuse. So the opposite leg over the hypotenuse. Cosine is going to be the adjacent leg over the hypotenuse, while tangent is going to be the opposite leg over the adjacent leg. When you do those calculations, it'll give you the numbers that they're looking for. So if we look at this, the reference angle is the angle that the problem is referring to. So if I'm talking about the adjacent side to that angle, it's the side that's connected to it. The opposite side is the side that's opposite that angle, or the side that the angle opens up to. Okay, so this is the opposite side. The hypotenuse is, again, the side that's opposite the right angle. What I do in class is we spend some time just identifying, if I were to talk about this being the reference angle here, this would be the adjacent side, that's the opposite side, that's the hypotenuse. So I almost always, in class at least, try to have everybody work through identifying what the sides are first. Adjacent, hypotenuse, and opposite. For this angle here, this would be the hypotenuse still. This is the adjacent leg because it's connected to this angle. And this is the opposite leg because it's opposite that angle. For this triangle, we've got, this is our reference angle. This is the adjacent, this is the opposite, and this is the hypotenuse. Okay, so let's talk about that. It's going down here a little bit. We've got, again, we're talking about SOHCAHTOA. Again, you have access to these notes. They're in the spreadsheet. You can click on it. You can see what it is I'm seeing, and you can have this down somewhere next to you so that when you do the calculations, you can find it pretty quickly. So if I want to find sine, sine again is right here. That's going to be, I need to take the opposite leg divided by the hypotenuse. If I'm looking for the cosine of the angle, I'm looking for the adjacent leg divided by the hypotenuse. And if I need the tangent of the angle, I need the opposite leg divided by the adjacent leg. Again, you can find this anywhere on Google. I mean, it exists everywhere, but just have it somewhere where it's easy for you to find. So when you do the calculations on this assignment, you can find it pretty quickly. Okay. So let's go to IXL for a second and take a look at, now understand, you're going to go within Algebra 1. I don't know why they put trigonometry in Algebra 1. I really haven't seen it there before. But in this case, we're going to HH1. So I'm going to click on that. And now it's going to ask me questions like, what's the tangent of angle I? Here's angle I. First thing you can do is identify, okay, for tangent, I need the opposite and I need the adjacent. So where are the opposite and where's the adjacent? Well, the opposite is here, 56. The adjacent is here, 33. So I need to take the opposite divided by the adjacent. So that would be 56 divided by 33. And they're asking me to go to the nearest hundredth. Well, it's 1.696. So my 9 goes up to 0, so that would become 1.70. Okay. Cosine of angle T. If I look at angle T, this is my adjacent side, this is the opposite side, and this is the hypotenuse. Cosine, again, if you go off the formula, is adjacent divided by hypotenuse. So that's going to be 5 divided by 13, which is 0.384. So if I round to the nearest hundredth, which is 2 places past the decimal, 0.38. Cosine of C, again, this is going to be adjacent over hypotenuse, so it'd be 65 over 97. So 0.67. And then tangent of angle S. So tangent is the opposite side divided by the adjacent side. So 4 divided by 3. So 1.33. Okay, so we need the tangent of C, which is going to be the opposite divided by the adjacent. Now, notice here that they're not giving us the length of the adjacent side. we have to use a Pythagorean theorem in order to figure that out. Remember, Pythagorean theorem is going to be a squared plus b squared equals c squared. So that'd be 15 squared plus x squared equals 17 squared. So I've got to square 15 and square 17. I'm not going to explain how to do the Pythagorean theorem again. I just want to make sure. I'm going to go through this. So 15 squared is 225, and 17 squared is 289. I'm going to need to do the 17 squared minus the 15 squared. So 289 minus 225, and I get 64. But remember, I have to take the square root of that. And plus, it wouldn't make sense for CE to be 64 anyway when these are 15 and 17. So the square root of 64 is 8. So I've got to do 15 divided by 8 in order to find the tangent. So 15 divided by 8 gives me 1.875, which would be 1.88. There we go. So just remember, for some of these, as we get farther along here toward the 40, 50, 60 range, we're going to need you to be able to use a Pythagorean theorem first, figure out the side, then do tangent, then do sine, then do cosine. But the first ones here are not going to be asking you that. You just have to do the opposite divided by the adjacent. You need to do the cosine, which is adjacent over hypotenuse, or sine, which is opposite over hypotenuse. All right, good luck.